Now, in this video, we will start our discussion on various smart grid measurements. So let's try to understand what are the various measurement technologies we are going to study. So we will start our discussion with the phasor measurement units. We will first see what is synchronized phasor measurements, and then we will see how phasor measurement unit, that is PMU, is utilized to get the synchronized phasor measurements. Then we will talk about the smart meters and the associated smart metering infrastructure. We will also talk about the wireless sensor network, because the wireless sensor network is a building block of Internet of Things. So first we will discuss wireless sensor network, then we will talk about Internet of Things, because Internet of Things is very important topic for power system network, particularly related to the data acquisition from the fields. Then we will also talk about the geographical information system. We will discuss why it is important for the power system network. Now let's start our discussion on synchronized phasor measurements. So as far as the history of the synchronized phasor measurement is concerned, the efforts to develop phasor measurement units started from Virginia Tech in 1982. The initial funding of the phasor measurement development was given by Bonneville Power Administration, that is BPA, then Department of Energy, American Electric Power, that is AEP, and then later by New York Power Administration, that is NYPA. So these are the initial funding agencies involved in the development of synchronized phasor measurement and phasor measurement units. The biggest breakthrough in the development of PMU happened when the GPS, that is Global Positioning System, that is nothing but a navigation system developed by US Department of Defense, and this became a game changer for phasor measurement units. Now, first full-fledged satellite was launched in 1989, and then by 1994 there were 24 satellites which were orbiting in 6 planes separated by 60 degrees from each other and 50 degrees inclined from Earth's equator. These satellites were making 2 revolutions per day around the Earth. The radius of Earth is around 16,500 miles. Now, at a time, 3 satellites are required for generating the 2D view, and 4 or more are required for generating the 3D view. So, utilizing the GPS technology, the phasor measurement unit was developed by Microdyne company along with the Virginia Tech University. First standard on the phasor measurement technology came in 1995. At that time it was IEEE 1344, which talks about only the nominal frequency. Then revised version of phasor measurement standard came in 2005, and which was given a name as IEEE C37.118, and it includes off nominal frequencies also as part of the standard. In 2011 we got an updated version of standard in the form of IEEE C37.118.1 and IEEE C37.118.2, which talks about the transient and dynamic compliance of phasor measurement units. Now later on in 2018 the effort were made to add the synchro phasor standard as part of IC standard, and then IC 60255-118-1-2018 came. Now this is similar to what we have as part of IEEE C37.118. The only change is that there are few considerations in respect to IC, and the synchrophasor unit is also considered as a intelligent electronic device, and accordingly the few suggestions are mentioned in this standard for power measurement using synchrophasor technology. Now let's talk about the global positioning system, because it will help you to understand why we need the satellites for synchrophasor technology. So global positioning system, that is GPS, is a highly sophisticated navigation system developed by the United States Department of Defense. It utilizes satellites technology with signal receivers and highly accurate clocks to determine the position of an object. The constellation of 24 high altitude satellites are part of the global positioning system. Satellites orbit in Earth twice a day, transmit precise time and position information at the Earth. So the time and position information includes latitude, longitude, and altitude information. A complete system of 21 satellites and 3 spares are part of the global positioning system. So this makes 24 satellites. It is used in activities such as traffic management, asset management, defense, utility, property mapping, infrastructure activities, and so on. GPS is anyway the most common application we use when we navigate along the roads, and GPS app which we use in mobile phones uses these satellites to navigate. Now in India also we have got the Indian GPS system, which is called as Gagan. So I would suggest you go through the website of ISRO and see what is Gagan. Based on that Gagan, we have developed GPS clock that is based on Indian GPS system called as NAVIC. So the NAVIC can also be utilized for getting the synchronized phasor measurement. So these we will discuss in detail when we'll go through the phasor measurement technology. This is just for you to understand that in India also we are making efforts in the development of Indian GPS system and Indian satellite clocks. Now, how GPS we will use in the power system? For efficient monitoring and control of power transmission distribution networks, we need the accurate measurement of voltage, magnitude, and angle at all the buses. And the measurement should be time stamped and measurement should be synchronized. If these three things are available, we can have efficient monitoring of the power system network. So let's take the example of sample power system network, where there are three clusters of the power system network, and the bars which you are seeing in the figure are nothing but the buses of that particular network. Say for example 1 is the bus 1 of the subnetwork 1, 2 is bus number 2 of subnetwork 1, and so on. Similarly, in case of subnetwork 2, 2 is bus number 2 of subnetwork, 1 is bus 1 of subnetwork. Similarly for 3, 1 is the bus 1 of subnetwork 3. So we have now 3 subnetworks which may be geographically apart and the distance is in kilometers, and we need to measure the voltage and current at the same time. So now if you see, satellite is the only device which can monitor all the points on the earth at the same time. So if we get the synchronized time information from the satellite, we can measure the value of voltage and current at any point on the earth with respect to a time which is being given by satellite. So the GPS, which is based on the movement of satellites, helps in a common access timing pulse which is accurate to less than 1 microsecond at any point on the earth. So that means the timing pulse given by satellite has an accuracy of 1 microsecond. So when you provide the timing information to all the 4 buses which are shown in the figure exactly at the same time with a delay of only 1 microsecond, we can measure the critical parameters like voltage magnitude or voltage angle with respect to each other and the current magnitude and angle and so on exactly at the same time. So because of this, we can say that the measurement which we got with the help of GPS and the satellite clock are synchronized measurements. So it helps in giving the time sampling data from the locations which are geographically apart. But can we say that the measurement is accurate? So we cannot say that measurement is 100% accurate because of the accuracy level of the measurement devices available at these locations. The accuracy of the measurement is defined. So in this way, we can utilize the GPS system with the help of satellites to get the measurement at any point and at any location on the earth synchronized with respect to the information which is sampled at the other end. So this is the biggest advantage which we get with the help of synchronized measurement.